We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration, Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration, Inc. has all your solutions down cold.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, ZoomLock Max Press to Connect, and ZoomLock Push to Connect refrigerant fittings. If the folks want to learn more, what do? You could go to sporlan.com. I guess that's Jim and John for Sporlan signing on.
Hi, guys. Welcome to another episode of the Advanced Refrigeration Podcast. I'm your host, Kevin Compass, and we're flying solo today. So we're going to go over something that's I've been doing a lot lately, and that's EMS conversions. So I'm going to go over some tips and tricks and things that I've learned along the way to kind of make these jobs go a little smoother and as less stressful as possible. I mean, they're always stressful, it seems like, but to try to make it as less stressful as possible. So with that being said, guys, here we go. We're going to dive right into it. So first off, I like to do a real thorough site walk when I'm bidding these. I am more thorough than usually what the scope of work says. I mean, you want to go through this entire store, top to bottom, look at everything. I'm looking at mechanical things. I'm looking at the controls. I'm looking at what I'm going to change to. Say if I'm going from Emerson to Danfoss, or Danfoss to Emerson, or Emerson to microthermal, or Comtrol to something. I'm looking at everything. I'm looking at the cabinets that I have that are provided that I have. Can I fit the number of boards I have to fit in there? Can I fit the number of power supplies and boards if it has to be in a train like microthermal or Danfoss, where it's all together in one train? Am I going to be able to fit that in the actual physical cabinet? So what I'll do is when I'm quoting these, I will, write down all the measurements of the boards. Like I'll have the Danfoss boards all laid out and the microthermal boards all laid out, like what the measurements are. So if I'm going in here I can look at a cabinet and be like, okay, it has this many inputs and this many outputs. How long does the board tray need to be? Am I going to be able to, am I going to be able to fit it? Where microthermal, this is very, very important because you can't extend a board train. You can't have just another circuit control train or we can have a circuit control train. You can't have another like suction group control train if you can't fit all the boards on there. So it is very important that like you need to lay that out to see if you need a cabinet, because a cabinet is a big expense on a job. I mean, a 24 by 24, like good cabinet, or 36 by 36 cabinet, maybe a couple $100. You know, you got to build that cabinet. So that's more money and more time. So what I like to do when I'm walking these is I'll measure out everything that I can to figure out what I could fit in these cabinets. With Danfoss, it's a little bit easier because obviously you can just have a second board train. It's just IO boards. Nothing has a processor in it. So it's a little easier on that side. You know, I'll go through and, okay, do I need 2 board trains? Am I going to have enough height in order to get everything in there and work and, make it look neat? Or do I have to have another panel? I'm trying to avoid having to put a panel in. It never looks as good, and it's a lot more work to add a panel. So even if I got to move some stuff around, move some transformers around, move some cable tray around, I will to make everything work. Now, the next thing I'm looking at is how short are all the wires? Like, are all my output wires going to be short? And it's going to become a problem because then it adds a bunch of time, and some of that can be pre-prepped up. Now, what I've been doing is, if it's not a rack where I could easily just take the wire and, take it off the terminal block and then put a new wire on and mark both ends, that's what I'm doing. But if I can't do that, say it's a older rack and that wire runs all the way down to the compressor, instead of pulling all that out, that's a ton of time, that's a ton of labor, and most of the time the customers are going to pay for it. I don't splice the wires. I don't use butt splices. I don't use wire nuts. I only splice wires in 2 ways in the rack, and that is with crimp connectors and with terminal blocks. I have been using the crap out of terminal blocks lately. On Amazon, you can buy a pack of like 200 35 millimeter dinner rope terminal blocks for like $20. So I have blue ones, red ones, orange ones, green ones, black ones, white ones. I have all kinds of different terminal blocks. So what I will do is I will take and say, if it's all like compressor wires, I'll take and I'll make all the compressor wires blue, and then all those terminal blocks are blue. And then say I have circuit wires, I'll make all the circuit wires red, and I'll feed them in there, and I'll make all the commons black. So I'll go red, black, red, black, red, black. So that way you could easily see where the circuit starts and stops. Now, I've been doing this. It's a lot easier. And if you have to splice these in a terminal block, it's more professional. It's the proper way to do it. And the other nice thing about this is some of this you could pre-wire. So you can pre-wire one side of terminal blocks all the way to the boards, and then just swap over your systems as you go. So that, in a sense, makes it a little bit faster. I've had to do that a lot of microthermal stores where I know that I'm going to be short and I had to fit the board train somewhere else. I will get a terminal block set. I will pre-wire all the boards. I'll maybe pull some CPC boards down or Danfoss boards down all the way. I'll mount my board train up there. I'll pre-pull the wires and I'll put them in the terminal blocks. And then all I do is grab the loads off of the old boards and then switch them over one by one seamlessly. That way I don't have to sit there and, fight everything. I just pre-wire everything to the terminal blocks. Everything's pre-marked and nice and neat on the one side. And all I got to do is worry about the load going into the terminal block and then marking those wires. It's a lot less stressful to do it that way if you have to. I don't prefer that. I prefer to obviously lay them on the board, nice, but obviously if the wires are going to be short, I don't want to wire none of them. I'm absolutely against butt splices. I think they look terrible, and I would much rather see it on a terminal block if you can. If you could take it down to a terminal block and like a Hussman rack where they have all the terminal blocks down there. That's great. I will, on the Hussman racks, I just pull the wire out. I put a new wire in the terminal block and then I rerun it up to the board. It's nice and easy. It takes a couple minutes longer a wire, but the overall looks really good. Now, the other thing I'm doing is I'm getting 16 gauge wire, which is kind of a pain to find. Usually got to go to a electrical supply house to get it. I'm getting 16 gauge wire. And if I could find it, it's a super flex wire, which is like what Hussman and Hill Phoenix use, that real like movable wire. I use 16 gauge for everything in the rack for the controls. It's way easier to work with. It doesn't fill the cable tray up as much. It doesn't put as much stress on the boards as you're like, getting all these wires in there and you're starting to, run everything in there. It doesn't put as much stress on the Form C contacts of the boards. So it's a lot easier. The next tip I've been using Phoenix connectors. What a Phoenix connector is it's a crimp with a shoulder that goes over the top of the wire and crimps down in a square. Now, what this does is this does two things. It alleviates any excess wire on the bottom of the wire sticking out past the board, and nothing's going to short or touch to another wire. And the second thing it does is it gives that board point a nice solid metal to grip against. And it's a lot easier to screw it down tight and get a good tight feeling, and it's not going to slip out because you're going to crimp it. I have 16 gauge ones, 14 gauge ones, 12 gauge ones, 22 gauge ones. I keep all these in a pack out tray, and I have it all separated. And for what I'm doing, if I'm doing the rack switchovers, I'm going to have a bunch of 16 gauge ones. I just have the little tray out of a pack out sitting there inside the rack. And there's a special tool for this. There's a crimp tool. It looks like a 4-jaw crimper, and you just crimp it, ratchet it right away. It's really seamless. And then it looks real nice because now all the terminal blocks, these Phoenix ones, fit right in there nice. You don't got to cut them. Everything's in there. It's all uniformed. It looks real good. There's no wires sticking out the bottom. There's no wires that are stripped a little too much or too little. Everything is in there nice and seamlessly. Now, when you go through and do these, you give them a little tug test and make sure they're good. And then I will either heat shrink labels on there. I'll get the labels depending on how tight the job is, or it's getting wrap labels. Now I generally label both sides of every wire, or I will label the wire where it goes into the common, or sorry, the normally open or normally closed. I usually don't label the commons. I mean, usually one label's good enough if it's compressor contactor or compressor one, or, circuit or defrost or refrigeration. One label is generally enough. You don't usually need to do two labels. I mean, sometimes it gets a little hectic in there with all the labeling. The heat shrink labels are real nice because obviously it looks real good, and, it gives you that extra protection to heat shrinking it. So those are nice. But the Phoenix connectors overall, the last like 5 jobs I've done them all on there. And like I did like 3 jobs out of 1 bag of Phoenix connectors. There's like 1,000 of them in there. So, I mean, they last for forever. I mean, it's like $18 for a pack of them. I mean, I use them on service. The other nice thing is, so say if you got like 2 16 gauge wires, well, you get a number 12 Phoenix connector, you could shove both wires up under the shoulder and crimp them like Hill Phoenix does in all their racks. It's the same connectors that they're using to like double up wires. So it looks way nicer when you go to do it. It looks more professional. So I use those. Now, anytime I got to double up on inputs, so like if I'm using like a 12 or 5 volt to feed transistors, I'll use the Phoenix connectors on there. I'll shove them all in like a 16 gauge Phoenix connector, and I'll crimp that down. And I'll crimp that down and use that to connect to the board. So that way I'm not, trying to shove 5 different wires in one board connection. So I have been using the Phoenix connectors slowly on the 22.2s. It's, I started 2 on the last job. It just takes like a minute or 2 longer. but it looks a lot better. I haven't noticed any problems with, readings off or anything because, I mean, you're still crimping down on the wire. Now, another thing that is like crucial for these jobs is a good EMS screwdriver and having backups. I'm terrible about losing these. I always keep backups. So I like the Klein 6-inch screwdrivers, 6-inch, their 1/8-inch slotted screwdriver with a 6-inch shank on it. So then it's like, and then a 4-inch handle. So it's like almost 10, 11 inches, give or take. And then the end twists. So basically, it's a real comfortable screwdriver. People think it's ridiculous, but like when you're doing, a couple hundred terminals a day, I mean, having that nice screwdriver that you could twist real easy, or it's longer, so you're not having to get your face in there, or you're getting back. I I love those screwdrivers. They're awesome. Klein makes the best control screwdriver you could buy for that. They're hard to find right now. I just had to buy like 6 of them off eBay, and I mean they're only $10 a piece, but they're like vital. Like I'll usually go through 1 or 2 a job. Walla, I think it's called. They're only like Germany. We bought 2 sets of their insulated screwdrivers. They're 1/8-inch ones. Real nice tool. It's a little short though. It's only 8 inches total instead of like close to 12. So that's where it or no, it's 7 inches total instead of close to like 10 or 11. It's not as comfortable. It's a nice screwdriver. It's insulated. If they made a longer one, that'd be great. Second thing that is like crucial is it speeds up so much time. Nipex scissors. Nipex makes electrician scissors. They are the best thing out there. I use them for everything: cutting wire, stripping wire, cutting zip ties. These things are great. They will cut your finger off in a second. They are so sharp. So you gotta be careful with them. But like stripping out control wires, it's all I use is these Nipex scissors, or stripping out wires on like even 14s and 12s and 16s and 10s, because all you do is nick the outside of the wire and it pulls right off. It's so sharp, it'll cut the sheathing on the wire instantly. Same thing with like cutting shielded cable to get the outside to get to the wrapping. You can instantly like make a nice little like groove in there if you're careful. Once you get used to like the scissors, you'll pop that thing right off, and then you could cut away the shield, and it also cut the white pull string. So it's super easy with that. Like those electrician scissors, I'll go through them. Like they do get dull. Like every couple jobs, I'll buy a new set. Like I probably got like 3 or 4 of these EMS jobs out of one set of scissors. They're $26. They're consumables. I'll buy them on the job. They're part of the job. I put them in the bid. I mean, all my guys have them. Like they're super sharp. It's a great tool. Now, for like stripping comm cables. So I like comm cables or shielded cables. What I'll do is I'll either tape or heat shrink the ends. I prefer heat shrink. It looks better, but electrical tape in a nutshell will work just as good. I mean, heat shrink looks a little better, and then I'll label the ends. So I'll trim them out, and then I'll heat shrink them and then label the ends. Or if I'm using the heat shrink labels, that's 2 birds with 1 stone. I prefer the heat shrink labels. And then I just use a heat gun, or if I'm doing a whole panel, I'll just get a 120-volt heat gun and I'll keep it running. And then that way I'll just clamp it to the side of the panel, and that way I get to stick the wire by it. And, every time I'm getting ready to finish one, I just stick it by it and then it automatically heat shrinks it. It makes that side of it a lot easier. Now, as you're going through and say you're doing, sensor pulls, you got to look at sensor pulls. This is where I struggle a little bit. I usually bring in the electricians. I personally try not to pull wire. I don't want to pull wire. It's not usually productive for me to pull wire because I don't do it all the time. So I'm not that fast at it. But the other senses, I could be doing something else while an electrician is pulling wire. Now, do I pull wire? Yes, I have to all the time. So just when you're pulling wire, The biggest thing is do your prep work first. Figure out your route. Figure out your route. Figure out where you're going to put your pull strings, your not pull strings, your eyelets. You know, put all your eyelets up, and while you're putting your eyelets up, run a pull string through while you're doing it. You know, as you're running like a line, you're gonna put eyelets up, put your pull string through. If you're gonna do a bunch of them, try to figure out as many cases as you're gonna pull at the same time. So, say if you're going through, you got to put a bunch of temp sensors in, and you're gonna pass by a bunch of cases. Start at the farthest cases first and pull those first, and then as you're going by, pick up more cases or you pick up more things. This is where I struggled in the beginning a little bit, and you want to try to pick up as many things as on a pull as you can. Shielded cable is usually generally pretty cheap. So even if you got like 2 or 3 extra boxes than you needed and we're pulling more, I mean, the labor outweighs the shielded cable. So say if I got to do, like 30 pulls, and if I could do, 10 boxes at a time and pick up all those as I'm going, and I'll just put the box by the case, and then I'll run them over and I can pull them all at once. If I could pull those at once and I can get them all done in a day, then rather like 2 days of, starting and stopping and pulling wire and getting everything in, I save a ton of labor there. Now, it's labor on these jobs usually costs more than material besides the boards and stuff like that. But like the actual like wire and stuff is generally cheaper. So just, keep that in mind, like lay your routes out. Like, generally I'll try to do it when I bid a job, but then, I mean, sometimes these jobs go like 3 or 4 months before they get awarded or like started. So I usually try to keep notes. I have my iPad, I keep everything on a notepad, and I write down all my notes in there for the job, how many hours I think it's going to take, how many hours I, bid for each item, discrepancies. I'll take some pictures. I use an app called Sign Out It Pro when I do my commissionings, and I also use it for doing bids. I'll take pictures of like stuff. So like I'll take pictures of this air handler I got to redo. Okay, here's the air handler, and then I'll write down all the measurements in it and whether I think boards will fit or not. And then I'll go through and, okay, I got to do this many cases, need sensors. Here's the route I want to take. I'll mark out the routes with arrows where I think the stringers need to go up, and then how many hours I think it's going to take. So I'll go through and I'll try to do that to try to be way more organized with it. So that way I could do the groundwork in the beginning. So when we do get on the job, it's not like, which I generally still end up having to take, like half a day to a day to get myself, all organized and like set up. Okay, we're going to do this day, this day. Here's our goals for this. I mean, I still end up wasting some of that time, but I waste less with having all of this within pictures and pre-measured and a game plan to go. Now, the thing is, when like I'm going through and I'm starting these, the first day I'll usually show up with all the material. I will get tables and I will set them up in the rack room or wherever I can. So there's a break room. I will set up a table or two, and I'll put all the material on there. Okay. All the boards, all the analog output boards, all the analog input boards, all the RO boards, all the comm modules. I'll put them all in there. I'll inventory them, make sure I have them all the temp sensors, all the power supplies. I'll get everything in a row. So that way, when we're doing this stuff, if we're just grabbing boards, we're just, grabbing here, boom, 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 boom. That way we're just grabbing the boxes we need. We know exactly where they are. We don't got to look. It's okay. This whole line is comm modules. This whole line is input boards. This whole line is output boards. This whole line is 0 to 200 transistors. This one's all 0 to 500 transistors. So we can just grab, be a little organized. It may take you like 3 or 4 hours to set it up and inventory it, but like that way, okay, like, boom, I'm going to need 5 boards over here, 5 boards over there. I could start setting all this up and get everything ready. If I'm doing DIN rail, I generally just grab it off of Amazon. You could buy a pack of 25 3-meter long DIN rails for like dirt cheap. And I will generally just cut it with a bandsaw. I just bring up the little M12 bandsaw up there and we just cut our DIN rail to whatever we need it. And then we'll slap it in with some Phillips head self tappers. I generally use the Phillips head self tappers because the 5/16 every once in a while will hit on the bottom of the DIN rail, the boards, and or the terminal blocks. So I'll use the flat panhead 5/16 or not 5/16, the Phillips head self tappers. They work out great. I'll go buy a bunch of Phillips bits, extended Phillips bits for the guys. So that way when we're doing it, we can easily lay it out. And then when I'm laying it out, if I'm doing a whole big panel, I'll use a laser. It's a lot easier just to get the laser level and then lay out the panel, put the DIN rail in, set it up, boom, shoot it in, shoot screws in. You don't got to mess with a whole bunch of stuff. You just move the laser and then shoot the screws again, and then lay out the panel, put your boards in, get everything powered up, get the comm on. And then if it's microthermal, what I'll generally do is I'll put the boards in, get them powered up. I'll get the program dumped in them the day before, and I'll disable all the transistor alarms, all the open sensor alarms. So that way it's going to see all these sensors are open. But what you could do in the meantime is with like microthermal is with the 700 boards is you could dump the program into it. You can get it ready. You could get it all online because it could take about two hours to dump that program in there, depending on how big it is. So you get it all ready. So the next day, all you got to do is start laying stuff on it. So what I'll do, the first thing I'll do is I'll take like 2 or 3 compressors, lay them on there, get them, half running on Emerson or half running on microthermal. And then once I feel like I got like decent control over it, like I'm half and half, I'll have the second guy working with me switch the transducers over, discharge transducer, suction transducer, and I'll let the new system, whether it be Emerson, microthermal, Danfoss, I'll let that start controlling everything. And then I'll start taking more compressors off of the other system, the old system, and I'll switch it over. Once I get past the halfway mark, I usually switch the transistors over, and then I'll start switching all the rest of the wires over. Now,
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
as I'm flowing through, I'm kind of making, making sure I'm not tangling wires up, making sure that everything's going through, cable tray that looks good. Or if I'm using zip ties, making sure everything's going through zip ties and everything looks clean and it's not tangled up, because nothing's worse than having to do this and like realizing, oh shit, I have to untangle all these wires, or like, oh man, I have a wire that's 2 inches short and it's like on an angle and it looks like cracked compared to the other ones. So it's just one thing to keep in mind. Now, the other thing is make sure that your landing is on the right terminals. Make sure that like if it's normally closed, it needs to be normally closed. If it's normally open, it's normally open. Generally, I'll put that in the bottom of the label. Like if I'm doing it, it'll be like compressor 1 NC. Like the second line will be like NC normally closed, or NO normally open. Whatever one I pull it off of. I try to keep the board points as similar as I can to what was there. So like if it's So for example, if it's Emerson that was in there before and it had an 8RO board, so I'll keep it 1 through 8 on that board will be 1 through 8 on there on the actual like retrofit board. So if it's, board 1 through 8, it'll be 1 through 8 on the Danfoss board. It may not be board 1, it may be board 2, but it'll be 1 through 8. I try to keep it all the same. Now, where it gets difficult with microthermal is only certain loads can go on certain boards. So you really got to plan this out. So you may have to flip flop stuff around. I don't like using the combo boards with microthermal, the four output, 8 input boards. I don't like using those because they eat up too much room in the panel. So I'll generally go with 1 input board in the suction tree and then a bunch of output boards in order to like kind of try to save space. But that is all dependent on the panel. I mean, everything with these retrofits depends on the room you have to work with and the amount and the customer spec. So generally what I'm doing with, like, I could usually move wires around and I'll tag them. But at the end of the job, I'll make a wire diagram and I'll make a point list. The great thing about like microthermal is you could print the point list out for the board. So it'll have a PDF that it'll generate for each board that you could go in there, save it and print it. And it has every single output and input on that board tray. Great. I would laminate them. I stick them in the panel and I tape them with shipping tape to the panel. I tape it with shipping tape because people could see it still and it's a bitch to get off. So nobody's going to take. Now, with Danfoss, I'm still kind of learning that. I think you could print out the board points. So I'll do the same thing with that. Emerson, what I'll do is I'll copy all the points down in Ultrasight and I'll either screenshot them or I'll copy them all, drop them in a Word file, and then I will take those and I will laminate them. So that way you have a point list and a legend list. It makes everything a lot easier. Now with Danfoss, make sure if you're going to do this, you take the time. Like I'm doing a job right now and I'm slowly starting to do it. I'll put the relay states. So if it's normally open, normally closed, you need to put that on there because Danfoss doesn't have fail-safe switches. So you got to put that relay state on there, whether it's normally open, normally closed. That's a big thing. So if somebody has to reprogram this, or if they're trying to troubleshoot it, they're trying to know what it does. That's a huge thing. With CPC, when I'm doing it, I will also put the dip switch state, whether it's up or down. So that way you have that in there when you're making these point diagrams. The other thing is mark the comm wires in and out. Every single board, as soon as you land them on the board, mark where it came from and where it's going to. It'll make your life a whole lot easier and the next guy to troubleshoot it. And then when you're done with it is make a map of the comm. Like I'm trying this eDraw Max. I'm going to try to do this comm map in eDraw Max. So basically I could, show the Danfoss boards and show where it goes to, where it comes from, where it goes to, where it comes from. So that way, if you have a big store like microthermal, it's key. Without a microthermal, it's a pain because you can't test voltages for comm. So splitting up the comm network on microthermal is a pain. So you need to know that map and needs to be accurate to where it needs to go. The other thing is when we're talking about comm stuff is following the customer spec for what wire you need to use and the way it runs, and then the manufacturer spec also. So try to keep the comm wires away from 460. I mean, try to keep them away from the 120 volt control. I know it's hard. You got to pick your routes the best you can. Try not to run over or alongside ballast. It's a retrofit. It's hard to do. I mean, just try your best to, keep it as, away from you as you can. Don't strap it to conduit that's got 460 in it or 208 because it's going to pick up noise. You could actually pick up voltage on that cable running next to that conduit through that shield. It'll pick up voltage from that conduit run. So that's another thing is that, spend time and, make sure you pick your routes and try not to run it, by anything, ground your shields if you have that much noise, and then make a nice map of everything and just lay out how you're going to do it. Like if you're doing stores and you're converting multiple controllers into one controller, that's a whole nother like thing. You need to plan out your comm loop because you don't want to start with the first controller and be like, oh, now I got a star here. I'm going to have a star when you're going to have to run a comm line where you could have just, ran two comm lines out and spliced it in the middle of the network. So that's one thing you guys need to really pay attention to is how you're going to do these. Are you going from 4 controllers to 1 controller? They're going from, say 4 control controllers to 1 Emerson controller. Well, now you got to lay out your comm lines. You may have to pull some wire before you start this in order to not end up with stars. You don't want stars. The only control system you want stars is microthermal. So you may have to take a day to like lay out and, pre-pull some comm lines. So that way you could pick up all these controllers without having to, massively backpedal. That backpedaling time ends up costing more time on the job than anything. So in repulling wire, that was a hard lesson for me to learn is the repulling of wire, or like not laying out these comm lines or not thinking ahead enough to say, okay, I'm done with this rack. Well, now I got to do this rack and the rack after. Well, what am I going to do for my comm line now? Because it's going to be a star. And then I ended up having to pull another line all the way back to the controller, which ends up, costing more time. And if you're running these jobs, is like the last hour of the day, I will try and set up tomorrow. So like the last hour of the day, I'll make sure everybody else on the job is, got a task still. And then I'm planning out the next day for all these guys. Okay, we're gonna do a rack. This guy's gonna finish this, and this guy was gonna start on, this stuff on a rack and do the circuits, and we're all gonna work together. I refuse to do these on a second guy. It's a lot easier. Like generally, I'll have one guy, putting board points in, and then I'll be doing like the wire switch over. That way they learn the programming side of it. And then I could do the wiring switch over, and it's a lot easier. And then I kind of enjoy doing the wiring. So what I do, and this is all dependent on the site, but like with microthermal, I do this every single time and it hasn't failed me yet. And I like the way to do it. So what I'll do is I'll call out board points as I'm wiring stuff. So I will not pre-program all the board points. I'll pre-program everything into where all I have to do is assign points. I will call out board points when I'm finishing this. So like I'll call out compressor 1 is relay 1-1-1, compressor 2 is relay 1-2, compressor 3 is relay 1-4. I'll tell like the next 4, and then like he'll pop them in there, and then he'll also be doing programming for other stuff, or like, finish leaking stuff to circuits, or finish leaking case programming, or make sure the alarm programming is all done. He's doing that while I'm doing the switch over. Yeah, it's not as efficient, but it works fairly well. And then I'm calling out the points, and there is no like, okay, this wire's too short. What now? Now we got to move points around and all this stuff. It's okay, this wire's going to be short. It'll reach 0.8. Well, now that goes on 0.8. I call out 0.8. Instead of having to go on 0.3, it's not as clean, but you know what? There's less time wasted on it. And it's all the factory wiring still. There's no splices. And to me, that's less room for failure. So that part of it is the way I do with MT. With Emerson, I can move the relays wherever I want. So it's a lot more flexible. Danfoss too. I've been programming a lot of the Danfoss stuff, if it all makes sense and I have room. Now, second thing is when you're doing programming is so you don't waste much time having to go back and clean it all up. Make sure your naming and labeling is to the customer spec and the alarms are to the customer spec before you go through and do it all again. Take the time. Yeah, I used to try to rush through program the controller, get a base program in, then I'll tweak it later. Well, I spend more time going back and, tweaking things and adjusting things. And with Danfoss, if you don't hit everything, everything will be in a row. So like say if you had air handler 1, 2, and 3, and then rooftop, 1, 2, 3, 4, 5, and 6. Okay, well, so say there was another air handler that was added that you didn't know about, you had to add it. Well, now you can't make it air handler 1, 2, 3, 4. You have to delete the first rooftop and make that air handler 4, and then redo the whole program from the way down. I don't have a ton of Danfoss experience, and I just had this happen to me, and it cost me like 6 hours of moving board points and naming. And yeah, do I think it's stupid? Extremely, but it took me a long time and to make it look good because it was all unorganized. With Emerson, everything's alphabetic, easy peasy. You can move it all. You just move your naming around, and everything's good. With Microthermal, you could drag and drop, move stuff around. You're kind of like canned on that side of it, but it's movable. It's more fixable and more nameable. So just take the time at the beginning and just do the whole program all the way through, customer spec for the alarms, make sure that's good, and then test everything when you're done. I do not leave for the day until we test everything we switched over, whether it's compressors, unloaders, circuits, make sure they go into defrost, make sure the hot gas works, make sure all that works, make sure condenser fan cycle, make sure they ramp down. Everything we do, we test before we leave. I don't want the service department there to have to deal with it. I don't want somebody to, come on my job and, we have panels all ripped apart and they have no idea what's going on. They have no idea what any of this stuff is. So I test diligently before we leave. Every case gets thrown in defrost. I make sure the defrost differential valves work. We make sure the pump outs work. We make sure everything, functions the way it should. We do a quick function test on it. Now, after we're done with the changeover, we do commissioning, meaning like we're going to go through and make sure every temp sensor is tied to the right case, to the right relays, meaning like if it's A01, when it goes in defrost, the temp sensors rise up, they come back down. I diligently check all of those against each other, make sure we're not cycling on temperature. And if we are, we adjust EPRs. That's not really part of this job, but part of it is making sure everything works properly and is commissioned properly. So you don't want this finger pointing game. Like you don't want the service contractor saying, hey, you did a shit job. And, we have all these issues, and you want to have as little issues as you can, but you're going to find stuff. You're going to find compressors wired wrong. You're going to find cases with 4 defrosts a day for 45 minutes for hot gas. You're going to find issues that were hidden. You're going to find all this stuff. Now just work your way through it. And you're going to have to make work orders and stuff. It needs to get fixed. If you're adding temp sensors and stuff, you're going to start finding stuff. We just found a case the other day where the lights were shutting off. And it's been like that for probably 10 years. Nobody noticed it because the store was closed. By the time they got there, the light cycled back on. No temp sensor in the case. Nobody noticed it. The case has been getting warm for however long it's been installed. They swapped the lights and the fan. So the lighting contactor was controlling the fans and nobody noticed it. Been going on for years and nobody noticed it. So stuff like that's going to pop up. That's where that commissioning is key. And then alarm management. You want to make sure all your alarms are, programmed, all your transistors are good, all your high pressure and high priority alarms are programmed. So that way you're not getting stuck with a bunch of food and, if something goes down. You're moving a ton of wiring around here. You're going to have issues. Just be diligent before you wrap up for the day. Every switch gets checked, make sure everything's at temp, make sure, there's not compressors banging on and off, make sure condenser fans are working, be very diligent before you leave the building. You don't want to leave a bunch of stuff down and then somebody ends up there or you end up with a product loss. I mean, that's an easy way to tank one of these jobs is, a product loss or, having the service department come out a bunch of times because, you're forgetting to turn stuff back on. You're, you move some wiring around and you lost a common. I mean, let's be honest, some of these racks are on their second or third retrofit. So, I mean, you're going to have times where you move a wire and it kills something else. So just be very diligent about that and make sure that, you're doing it properly. One last thing is hot gas guys or electric defrost. You should be using 2 relays. You should be using a refrigeration relay and you should be using a defrost relay. Now, the way this should be set up is the normally open of the refrigeration relay should feed the common of the defrost relay. So that way, refrigeration has to be off and defrost has to be on in order for defrost to work. The reason this needs to be this way is you don't want the hot gas solenoid or the contactor reveal to energize with the refrigeration on. Because if it's hot gas, it's going to allow that hot gas right back into the suction header. So if somebody forced a relay, if somebody flipped a dip switch or flipped the HOA switch, now they're allowing that defrost gas, to seep in there, that contactor to be on, and you're going to end up overheating compressors. So that is a safety, basically. It's an interlock wire. So refrigeration, it gets wired normally closed. The common of the defrost relay gets fed to your normally open of your refrigeration relay. And that's what, powers defrost. I pre-wire all these. So I'll go through and I'll make jumpers with the Phoenix connectors on there. And I'll jump normally open to common, normally open to common, normally open to common to each one. So that way I don't have to do that when I'm doing it. I don't have to pull the jumpers out of the old stuff because 90% of the stuff is wired that way. I don't have to pull any of the jumpers out. All I got to do is land my common on the refrigeration relay, my normally close the refrigeration relay, and my defrost wire on there. All I got to do is land those. Easy peasy. It's a lot easier. That little, bit of prep work on the jumper saves a whole bunch of time. Same thing with rooftop units or air handlers. Say you got, cool 1, heat 1, cool 2, heat 2. I'll pre-make the jumpers on there because generally we're just controlling the, thermostat inputs. So I'll pre-make the jumpers on all the boards. So if we're doing, say, rooftops for, 2 days, I'll pre-jump the commons all together. So that way all my guys got to do is grab the board, throw it in there, and wire up the, Y1, Y2, W1, W2, and then the fan proof if we have it. It makes that part of it a lot easier. It makes it so you could fly through the rooftops and, get that stuff done a lot more quickly than you would be sitting there and pulling every single wire out and doing it all in the field. Like right now we're doing it in the wintertime, so it's colder. So just having that all pre-done and pre-prepped up in the DIN rail pre-cut and everything pre-ready to go, you may have filler time at the end of the days where everything's done. You're not going to start another project. Say it's, 1:00 and you guys leave at 2. You're going to start another project, start prepping rooftop boards or start prepping rack boards, get them ready. So that way, when you go to the changeover, everything's there. I will have everything set up and set out for that. Like I'm doing a rack, all the boards are set there. I'll have the boards for the compressors, the boards for the circuits, all that pre-made up. DIN rail cut if it's DIN rail mounted. If it's Emerson stuff, it'll all be pre-mounted. I try to pre-mount everything the day before. And then that way I just leave the boards hanging loose. If you're doing Emerson stuff, the pink foam they send with it is great to wrap the old boards in and hang them. Zip ties, if you're doing CPC to something else like microthermal, I generally will shoot a hole in the back of the plastic trays and I will hold it up with zip ties to the panel, or I'll shoot a screw in the ceiling and I'll use zip ties to hold up the boards. Works great. Comtrol is an absolute disaster joke because the boards are sideways. They already short in that like metal frame as it is. So you're going to want to wrap them in, cardboard or foam or something. So that way you could just pull the wires out when you need to and then move them. And that way they're not shorting. I generally will leave them hanging and I'll do a board at a time till I like get them all out. And then I'll cut the comm lines out of the way and then, go forward with that. But I generally try to do one board at a time and I will try to keep it as, organized as I can. Emerson's like really cake, like I said, because the boards have that plastic backing on the back and you don't have to be as careful. Like the Comtrol ones are bare or the old Emerson stuff's bare. That's a pain. Danfoss, same thing. It's really easy. You could leave the boards hanging. They are 100% protected on the back. Like nothing's going to short. So those ones are easy. So that makes for an easy switch over. Microthermal, the older stuff's like Emerson. So it's got the plastic backing. Same thing. I'll hang them loose and then I'll switch them over. I mean, the 700 boards, I don't know why you'd be switching anything over from, 700, but yeah, it's 100% sealed like a Danfoss board in the back. So guys, that was, my quick tips on, what was it quick? It was pretty long on doing EMS conversions and what to look for when you're bidding them and how to lay them out. And we'll go more depth into this on bidding them on the next one. After I get a couple more of these under my belt, I feel a little more confident about it. So, all right, guys, have a nice one.